and welcome. So for the video today we're going to be graphing a parabola. Specifically we're going to be graphing a horizontal parabola. Right? For anything for parabolas, the first thing you got to know is you have to know for sure what direction you're looking at, right? And how you can tell that is by looking at your equation. So for here, we have y plus 2 squared. Now, where that square is tells you exactly what direction you're going. For this one, you're either going to the left or you are going to the right. Now, how do we know which one is that, right? Left or right? And how we can tell is by looking at our number, or we can find the focal diameter. And that's going to be -4. Alright, well, think about it. If you're going left or right, which direction is a negative number? Left, right? Which means this is our case. We're going to be going left for our parabola for this one. Okay, so when we're looking at that one, then I'd say, alright, going left, and then we'd be using our general equation for parabolas. So that would be y plus k squared equals 4p x minus h. Oh, not plus, minus k. Alright, and this is your general equation for a horizontal parabola. So then we just keep it running from there. And we'd say, alright, now that we're going to the left, what we need to know now is we need to know the p-value. And so our number is -4, so that means 4p equals -4. How would you solve for the p-value? Well, that's dividing by 4, both sides, and then p equals -1. And this is going to be where a lot of the work comes from. Is because once we know we're going horizontally, specifically to the left, we know the focus is within the direction of opening, and we know the directrix is behind the parabola. And what's cool about knowing the p-value is that we know that that value is going to be a p-value to the focus, a p-value to the directrix, and we know the next points on the parabola will be a 2p distance from the focus both ways. Okay, so we can essentially just find it. So once we know our vertex, well, our vertex is just h comma k, where h and k can be seen from those original shifts with the x and the y. Notice that it's subtraction here, so we're going to be using the opposite operation of what we see. So with the x, because all coordinate points are x comma y, right? So then you'd say, alright, so -3, what's the opposite of negatives? That's a positive, right? Same thing, what's the inverse of addition? Subtraction. Okay, so your vertex is at 3, -2. So 3, -2 point, right? Here is your vertex. Okay, in order to find the focus, we're now going to go a p distance to the left. Now our p is -1, but if we're talking about a distance, right, that's just a distance of 1. Distances can't be negative. So we know we're going 1 to the left. Bam, focus. Same thing, we know if we're going 1 to the left, then 1 to the right will be your directrix. Okay, so now we know all of that lovely information. So focus is going to have to be at 2, -2. And the directrix has to be, because it's crossing the x-axis, at 4, it's x equals 4 is your line for this one. Okay, now if you want to look at the formulaic way to find this, because it's going horizontal, we'll be adding your p-value to h, and then comma k, and this will be x equals your h value, but subtract p. And those are the formulaic ways. So if you take your vertex value, which is 3, plus p, which is -1, comma -2, we'll get the same thing. Because what's 3 plus a -1? That's the same thing as 3 minus 1. That's 2. Right, so you could go the formulaic approach, or if you know like your straight definitions and relationships, that's in my opinion, a little faster way to go for these ones. Okay, and now all we got to do is grab the other point on our parabola, which we know that from our focus is a straight 2p distance up or down. Well, if our p distance is 1, that means we're going up 2, there's your other point, and down 2. There's your other point. Oops, so I go down 3, down 2. Okay, and it's always from your focus, because we know the parabola has to go up, right? It can't mystically do like a straight line. So we have that nice curve in there. Okay, so make sure when you're using your graphing tool, so make sure you're using the right one. This is your horizontal parabola. It will force you to graph your vertex first. Then you can graph either this top point or the bottom point. As long as you grab either one, it'll graph that one correctly. Okay, now specifically, the only thing it wants on that graph is it wants the parabola itself. Alright, it says graph the parabola, that's this thing. Okay, does it want any of those three dots on there? No, it doesn't. Okay, it just wants the parabola itself. The little red dots for placers aren't actually dots on the graph. Okay, you don't need the dot tool on top of them. Just use the red tools, or just the red dots are just placers for the actual shape. So don't worry about those too much. Then you have the focus, which that point right there actually put a dot for it. And then you have the directrix, which is this line. The line you're going to be graphing isn't dotted. That's okay. Don't freak out. Okay, and that is it. That's graphing a horizontal parabola. That's all the information you need. Thanks for watching.